Welcome students to online classes of mathematics for class 9th. In this video, we're going to study chapter number 10, which is circles of NCERT textbook. And we'll be looking at the exercise 10.5. As we'll be doing the first few questions of exercise 10.5 and the theorem. So that's why I've written it as part 1. Okay. This is the session number 5 for this particular chapter. Myself, Deepak Gautam, teaching mathematics in Kendriya Vidyalaya Sangathan. So let's start with our today's class. Chapter number 10, circles, divided into totals 8 subtopics, out of which we have already covered the first 6 subtopics in the previous sessions. Okay, today we'll be looking at the 7th and the 8th one, which is the angle subtended by an arc of a circle and also the cyclic quadrilateral. Okay, so let's start with the first one. We have angle subtended by an arc of a circle. Based on this, we have this theorem 10.8, which is a very important theorem. Okay, you will generally find some question based on this theorem in your exam. Okay, so the statement of the theorem is angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Okay, so we have the angle subtended by an arc. So we have an arc. That arc is subtending angles, one at the center and one at the any remaining part of the circle. Okay, the relation between the two is the angle which is in the center will always be double the angle which is at any point on the remaining part of the circle. Okay, for example, you can see in this figure we have this arc PQ. This arc PQ is making one angle at the center that is POQ, this one, and also this is making another angle on the remaining part of the circle which is PAQ. Okay, so from this figure you can clearly notice that the measure of the angle at the center is double the measure of the angle on the remaining part of the circle. Okay, which means if the measure of this angle is 50 degree, then this angle will be 100 degree. Okay, so if this angle is 40, then the angle in the remaining part will be its half, that is 20 degree. Okay, so whenever we have an arc and if that arc is making two angles, one at the center and one on the remaining part of the circle, then the angle at the center will be double of the angle which is on the remaining part of the circle. Okay, so we are going to look at the proof of this theorem now. Okay, let's start its proof. First we're going to write the given part. Okay, let's write the given here is an arc PQ of a circle subtending angles. Okay, we have an arc PQ which is subtending angles. One angle is POQ, which is at the center, and another angle that is PAQ at any point. You can write at any point on the remaining part of circle. Okay, what we have to prove here is we need to prove that the angle POQ is equals to the twice of angle PAQ. Okay, this is what we have to prove. We can prove this for the any of these three figure. Okay, we'll be considering the first one. Okay, this will also be true for the other two. Okay, so we have to prove that the angle POQ is double of the angle PAQ. Okay, so first we are going to start with the construction. Here the construction, what we're going to do is we're going to add this A to O and we'll subtend it to point B. Okay, so construction is join AO and extend it to a point B. Okay, so what we have done, first we have joined AO and we have extended the AO to a point B. Okay, so this is given to prove in the construction part. So let's start this proof now. So in this theorem, what we have is we have studied theorem in the chapter number 7, which says which is called the exterior angle property of the triangle, which means the exterior angle of a triangle is equal to the sum of the two opposite interior angle. Okay, so for this exterior angle, that is angle BOQ, its opposite interior angle will be OAQ and OQA. Okay, so we have in triangle, we have the triangle this BAQ. In triangle BAQ, we have what we have is angle BOQ is equals to the sum of angle OAQ plus angle AQO. Okay, this is the by the exterior angle property. Okay, exterior angle property of triangle. Okay, so by that property, the exterior angle will be equal to the sum of the interior opposite angle. Then we have also in triangle OAQ, we have OA equals to OQ. Okay, you can see this OA and OQ are equal. The reason for this is both are the radii of same circle. That is, the radius of the same circle will always be equal. Okay, now based on this, we have studied another theorem which says the angle opposite to the equal sides are equal. Since these two sides are equal, therefore their opposite angles, so right, therefore their opposite angle, that is angle OAQ, will be equals to angle OQA. This is by the angle opposite to the equal side. Okay, you can say angles opposite to equal sides are equal. Okay, that means this is the equilateral triangle, not equilateral, this is isosceles triangle. Okay, in which the one pair of opposite side is equal. So what we have here, we have this angle BOQ is equal to sum of angle OAQ and AQO, and we have proved that these two angles are equal. So this implies that we can write this angle BOQ can be written as the twice of angle OAQ. Okay, since these two angles are equal, so we can write this as twice of angle OAQ. Let's name it equation number 1. Similarly, first we have did it for this angle, now we can also prove this for angle POQ. Okay, in that case the angle BOP will be equals to twice of angle OAP. Okay, let's name it equation number 2. Okay, in similar way, this angle will be equals to the twice of angle OAP. Now what we're going to do is we're going to add the two equations. Okay, so let's do on adding equation 1 and equation 2, we get what we get is this angle BOP plus angle BOQ equals to, from here we can take this 2 common, so what left inside is angle OAQ plus angle OAP. Okay, so when you add these two angles, we'll get angle POQ. Okay, and after adding these two angles, we'll get twice of angle PAQ, and this is what we were asked to prove, that the angle at the center is twice of the angle at any point of the remaining part of the circle. Okay, so that's the proof of this theorem, hence proved. Okay, this theorem is very important. Okay, you will generally find some question based on this theorem in your exam always. Okay, and sometimes they also ask the proof of this theorem. Okay, this is a fundamental theorem, that's why it's very important theorem. Okay, now moving ahead to the next one, we have theorem 10.9. this says angles in the same segment of a circle are equal. Okay, so what we have is we have this arc PQ. Okay, this arc, from here we can make as many as angle we want to make in the any of the segment. Okay, let's make the angle in the major segment. Like we have this angle PAQ and PCQ, and these two angle will be equal. Okay, because they are the angle in the same segment. That's why this theorem says angles in the same segment of a circle are equal. This implies that angle PAQ will be equals to angle PCQ. Okay, we can also draw different angle, like here let's name it point D. We can also draw angle, let's name it point E. Okay, we can draw some more angles here like this, and we can name it as F. So this all angle will be equal. This PAQ will be equals to PDQ will be equals to angle PEQ, and it will be equals to angle PFQ. Okay, as these all are the angle in the same segment of the circle. And that's what this theorem 10.9 says. Angles in the same segment of a circle are equal. Okay, now moving ahead to the next one, we have theorem 10.10. It says, the statement of theorem is, if a line segment joining two points subtends equal angles at two other points lying on the same side of the line containing the line segment. So what we have, a line, if we have this line segment, okay, and if we have any 2 points on the same side of the line segment. Okay, so it says if a line segment, which is this one, joining 2 points which we have here, let's name it A and B, subtends angle at two other point lying on the same side. Same side means either these 2 points should be on the upward side or here downward side. Okay, so if we join these, let's name it this P and Q. If we join this PA and AQ, similarly if we join this BP and BQ. Okay, so if these two angles are equal, then this will be a cyclic quadrature. That means if you join these, you will get a circle like this. Okay, that's what this theorem says. Okay, so it says if a line segment joining 2 points subtend equal angle at the two other point lying on the same side of the line containing the line segment, the 4 points lie on a circle. Okay, if these two angles are equal, then this 4 point A, B, C, D must be lying on a circle. Okay, and if these two angles are not equal, so if we take point C and E, you can clearly see the angle C and E are not equal. Okay, that means C and E are not lying on the circle. Okay, similarly if you have any other point which is like we have E dash, again the C and E dash are not equal, so this E dash is not lying on the circle. Okay, if they are equal, they will certainly lie on the circle, or if they are not equal, then they are not on the same circle. That's what this theorem 10.10 says. Okay, now next we have this part number 8, which is cyclic quadrilateral. Okay, this is also very important topic. The first we have to understand what is a cyclic quadrilateral. Okay, cyclic quadrilateral is a quadrilateral ABCD is called cyclic if all the 4 vertices of it lie on the circle. Okay, if we have a quadrilateral, let's say this ABCD, if all the 4 vertices of this ABCD are lying on the circle, then it will be called cyclic quadrilateral. Okay, that means this point A, B, C and D, since these all 4 points are the part of the circle, that means they are lying on the circle. This means this ABCD is a cyclic quadrilateral. This is the definition of the cyclic quadrilateral. Okay, that is a quadrilateral ABCD is called cyclic if all the 4 vertices of it lie on the circle. Okay, then we have one important property of cyclic quadrilateral, which says in a cyclic quadrilateral opposite angles are equal. That is not equal, their sum is 180 degree. Okay, that's angle A plus angle C, you will always find that their sum is equal to 180 degree. Okay, similarly angle B plus angle D will always be 180 degree. This is the property of cyclic quadrilateral. Okay, If it is a cyclic quadrilateral, they will certainly satisfy this property. Okay, if they are not satisfying this property, then that will not be a cyclic quadrilateral. Okay, so we have next two theorem. First is the sum of the either pair of the opposite angles of a cyclic quadrilateral is 180 degree. Okay, that's what I was telling you. That is, this theorem is saying same thing. The sum of either pair of opposite angles of a cyclic quadrilateral is 180 degree, which means angle A plus angle C will always be equals to 180 degree if this is a cyclic quadrilateral. Okay, if they are not equal, then it will not be a cyclic quadrilateral. Okay, and also angle B plus angle D will always be equals to 180 degree. Okay, because they are the opposite pair of the angle of a quadrilateral. And next theorem 10.12 is the converse of 10.11. So it says if the sum of a pair of opposite angle of a quadrilateral is 180 degree, then the quadrilateral is cyclic. Okay, so what we have, if it is a cyclic quadrilateral, then the sum of the opposite angle will be 180 degree. Okay, or if the sum of the opposite angle is 180 degree, then it will be a cyclic quadrilateral. Okay, so these are the few theorems we have, and based on this we have exercise 10.5. okay, all this theorem will be used in the questions of exercise 10.5. okay, now let's move to exercise 10.5. The question number 1 of exercise 10.5 is, in figure 10.63, A, B and C, we have A, B and C are the 3 points on the circle with center O. So we are given 3 points A, B and C on a circle with center O, such that angle BOC is 30 degree. So this angle BOC is given as 30 degree, and also angle AOB is given as 60 degree, which is here. Okay, what we have to do is, now if D is a point on the circle other than arc ABC, so we have another point on the circle which is D. Okay, other than arc ABC, we have to find the value of angle ADC, that means angle this one. Simply, so let's write its solution. This is answer number 1. Okay, so from figure you can see that this arc ABC is making 2 angle, or we can write this as angle AOC, which is sum of these 2 angle. Okay, so we'll write, since arc ABC is making the angle, that angle is angle AOC, and AOC is the sum of the angle AOB plus angle BOC. okay, so now AOB is given as 60 degree while BOC is given as 30 degree. okay, so the sum, that is the value of angle AOC, will be 60 plus 30 is 90 degree. okay, so what we got is, we got an angle made by an arc AC at the center which is equals to 90 degree. Therefore, or we can say, since angle AOC is the angle made by the arc AC at the center, and ADC is the angle made by the same arc AC made by the same arc AC at a point D on the circle. okay, so therefore value of angle ADC will be the half of the value of angle AOC. okay, this is by theorem 10.8. okay, which says angle of this at the center will be double of the angle which is made by the same arc at any given point on the circle. Okay, so this is using theorem 10.8. so what we got is angle ADC will be equals to half of angle AOC. AOC is 90 degree, so the answer is 45 degree. Okay, so that's the answer of the question number 1. Okay, simply we have to add these two angles, so this will be the angle at the center by the arc AC, which turn out to be 90 degrees. So it's the angle made by the same arc on the remaining part will be its half, which is turn out to be 45 degree. Okay, so that's the answer of the question number 1. Now moving to the next one. Question number 2 is a chord of a circle is equal to the radius of the circle. So we have a chord in a circle which is equals to the radius of the circle. We have to find the angle subtended by the chord at a point on the minor arc and also on the point on the major arc. Okay, so let's first draw its figure. This is the figure for this question. We have this chord PQ which is equals to the radius of the circle. Okay, radius is OP and OQ, and we have this chord PQ which is equals to the radius. This chord is making two angles, one in the major arc and one in the minor arc, so we have to find the value of these two angles. Okay, so let's start this answer. Answer number 2. So what we have here is, since the figure is not given to us, so we'll write let PQ be the chord equals to the radius of a circle with center O. Okay, so PQ is a chord which is equal to the radius of a circle with center O. That is this OP is equals to OQ is equals to PQ. That means this chord PQ is equals to the radius OP and OQ. Okay, so again can say therefore POQ is an equilateral triangle. Okay, since it's all three sides are equal, so POQ is an equilateral triangle with all its angle equals to 60 degree. Okay, so therefore POQ is an equilateral triangle and angle POQ will be equals to 60 degree. Okay, now we're going to find the value of the other two angle, that is angle PAQ and angle reflex angle PBQ. Okay, so let's start. Since PBQ makes reflex POQ which is equals to total angle is 360 degree and the angle POQ is 60, so reflex angle POQ will be equals to 300 degree. Okay, this is POQ. Let me write this again. This is POQ. Okay, which is now to be 300 degree, and this is the angle made by the arc at the center. Okay, therefore angle PBQ will be equals to half of angle, or you can say reflex angle POQ. Okay, so that means PBQ is half of 300, that is 150 degree. Okay, so we got the value of angle PBQ is 150 degree. Okay, since this is a 60 degree angle, so its reflex will be 300, so this angle will be, which is in the minor arc, is 150 degree. Okay, now we'll calculate the arc angle in the major arc, that is similarly angle PAQ will be equals to half of the angle POQ. Okay, and POQ is 60 degree, so this will be 30 degree. Okay, that's the answer of the two angle. Okay, so measure of the angle in the first we are asked to find the minor arc. In minor arc the measure of angle is 150 degree, and in major arc this angle is 30 degree. Okay, that's the answer of this question, or we can write in the end, hence angles subtended by the chord on the minor arc is 150 degree, and on the major arc is 30 degree. Okay, so that's the answer of the question number 2 for exercise 10.5. Now moving to the next one, question number 3. The question number 3 is in figure 10.37 we have angle PQR which is 100 degree. It's given here. Okay, where PQ and R are the point on the circle with center O. So we have these 3 points on the circle. We have to find the measure of angle OPR. Angle OPR is given here. We have to find the measure of this angle. Okay, this is very simple. Since this angle is given as 100 degree, so its angle at the center will be this one, which will be of its double, that is 200. Okay, so this opposite angle will be 160 degree. Okay, since these two sides are equal as they are the radii of the same circle, so their opposite angle will also be equal. That means the value of each of this angle will be 10 degree only. Okay, let's write this answer. This answer number 3. So what we have is, we have angle PQR equals to 100 degree, which is the angle subtended by the arc, which is the angle subtended by the arc PR on the circumference of circle. Therefore since this is the angle made by this arc PR at any point on the circle, therefore its angle made by the same arc at the center will be twice of this, that is angle POR, that is this will be reflex angle. POR will be twice of angle PQR. So since this angle is given as 100 degree, so this will be 200 degree. Okay, so this reflex angle POR is 200 degree. Therefore we can say, so angle POR will be equals to 360 degree minus reflex angle POR. Okay, so this will be 360 degree minus 200 degree. This will be 160 degree. Okay, so angle POR is 160 degree. So all right, now in triangle, so we'll take now this triangle OPR, or we can say POR. We have OP is equals to OR because they are the radii of same circle. Okay, the radii of all the radii of the same circle are equal. So this will implies that their opposite angle, that is angle OPA, sorry, OPR and ORP will be equal. Okay, angle OPR will be equals to angle ORP. Okay, that is the angle opposite to the equal side of a triangle are equal. Okay, right, angles opposite to the equal sides are equal. Okay, so these two angles will be equal. So therefore in this triangle we can apply the angle sum property, that is angle POR plus angle OPR plus angle ORP has to be equals to 180 degree. That is the angle sum property. Angle sum property of a triangle. Okay, so POR we have calculated, which is 160 degree, and since these two angles are equal, so we can write it as twice of angle OPR equals to 180 degree. Okay, so therefore twice of angle OPR will be equals to 180 degree. This 160 will become minus 160. So from here angle OPR will be equals to 180 minus 160 will be 20 degree, and this 2 will come in the division. Therefore the value of angle OPR is equals to 10 degree. So that's the answer for this one. Okay, we got the value of this angle as 10 degree. Now moving to the next question. Question number 4 is, in figure 10.38, angle ABC, which is here angle ABC, is given as this one 69 degree, and angle ACB, which is here angle ACB, is given as 31 degree. We need to find the value of angle BDC, this one. Okay, so first we will apply the angle sum property in the triangle ABC. Okay, so let's try this answer. Number 4. So we'll write, in triangle ABC we have, okay, so we can apply the angle sum property, that is angle ABC plus angle ACB plus angle BAC will be equals to 180 degree. Okay, this is the angle sum property of triangle. Okay, so we got the value of these two angles. ABC is given as 69 degree plus ACB is given as 31 degree, plus we need to find BAC from here, that is equals to 180 degree. So BAC from here will be 180 degree. This 69 plus 31 will give us 100 degree. So angle BAC will be equals to 80 degree. Okay, therefore, or we can write, since angle BAC and angle BDC are the angles in the same segment, therefore angle BDC, which you have to find, will be equals to angle BAC. That means angle BDC will be equals to 80 degree, and this is by the theorem angles in the same segment of a circle are equal, that is theorem 10.9. So you will write the statement of theorem 10.9, that is angles in the same segment of a circle are equal. So we got the value of angle BTC. Okay, so we have completed first 4 questions of exercise 10.5. okay, so we'll be covering the remaining question in the next session. Okay, so for that's all for now. Thanks for joining here everyone. Thank you.